So it's a new year. So for you watching in real time, it's been a bit of a quiet bit since I last made a video, but that's not because a lot isn't happening. It's just not visually entertaining stuff. I got some stuff in and I want to open it, but I want to show you what I got as I open it and figure it out for myself. So while I open this, I want to give you an update on everything that's been happening very briefly, but a longer conversation on the wiring, because let me make some space here for putting something on screen. I have spent just the last 3 days learning how to do electrical schematics and drawing and asking my patrons on the Discord and asking friends, does this look good? Getting feedback, getting corrections, refining it, expanding it, adding more detail. And I think I've got it mostly sorted out. So I have spent a lot of time talking about having two Multiplus-IIs. I was going to get a 230 volt Multiplus and run it, just basically switch the shore power connection between whichever one I need for the given electrical region that I'm in. I have decided not to do that. So I've come full circle and I'm back to using the isolation transformer auto voltage. I was calling it an auto transformer and one of the patrons was like, that's not what this is. So I'm trying to get out of the habit. It's an auto voltage selecting isolation transformer or something like that. Why? If I can find a 50 amp 120 volt shore power connection, I would go from being able to get about 3,600 watts off the shore power to about 4,000 watts off the shore power. That's not a small difference. It's more than 10%. So when I sat down and tried to finalize the wiring diagram, I came to the realization that I should have realized a long time ago, and that is that most 50 amp circuits that you can get, at least in North America, are provided by having two phases. Line 1, 120 volt, line 2, 120 volt, neutral and ground. I wouldn't be able to take advantage of that anyway because I only have a single phase, single line. I'm still learning the terms. Multipluses. So I couldn't benefit from that. I would have to find somewhere that somehow had 50 amps at 120 volts, which seemed pretty unlikely. As I understand it, in Europe, it's very similar. So with that in mind, I was also looking at the cost of an ELCI or RCD type breaker. They were like $500 or $600 Canadian. I was going to need something that could do over 50 amp galvanic isolation. So I was looking at like the Victron VDI64, which is another $400 or $500. It became a big thing. What really put the nail in the coffin for that idea was the realization that exactly where I want the fastest shore power charging is going to be along rivers and canals where large vessels can't go. The chances of me finding one of these hen's tooth shore power connections is as close to zero as it might as well be. Does that make any sense? Anyways, if I went back to just having 16 amp 230 volt or 30 amp 120 volt, everything got a lot easier. And by going with the isolation transformer, I don't need an ELCI breaker, which is dramatically cheaper, and I don't need a galvanic isolator. The cost of the galvanic isolator and an ELCI breaker was more than buying the 3,600 watt isolation transformer. So that's what I did. Let's open it. I felt bad when the delivery driver pulled up front because we're in the middle of an Arctic blast. It's like minus 13 degrees Celsius today, and this thing is not light. Made me wish I had a hot chocolate or a coffee to offer the poor guy. Also, one of the other things that happened since I got back, I sold my car. Lots of reasons, but the biggest is with that money, I'm still looking. I don't have anything else to replace it yet, but I'm looking for like a beater truck to just get me between now and when the boat goes in the water. But that frees up a lot of capital that allows me to hopefully afford the rest of this conversion. The other benefit to this, if you recall when I was talking about one of the reasons why I got the Multiplus, it was to save weight. This is, I think, like 7 or 8 kilograms less than the Multiplus, but then I also don't need the big galvanic isolator. So all in, I think I saved just shy of 10 kilograms by going this way. Another thing that happened last week, hey, Miss May. Little Miss May got old enough that she needed her, well, let's just say I would have made Bob Barker proud. She's recovering nicely, but that's why she has the cone on. And honestly, she's kind of an oscillator right now. Every time she walks, it's like she's constantly trying to turn away from the cone, and she does this like head wobble, snake slither type way of walking, and it makes me feel really bad, but it's also kind of really cute. Yes, I'm talking about you. Oh boy. It's lighter than the Multiplus, but that doesn't mean it's light. Bag broke open. I will say again how much I miss having these handles that the Quattro had that are not on the Multiplus. Victron, please put the handles back. Okay, I mean, it's basically a baby Quattro. Okay, I mean, it's a pretty damn simple device on temperature and whether it's 230 or 115, but I don't know if that's input or output. I'm assuming there's probably jumpers. Actually, let me pull you in and I'll crack this open. Now, while I'm opening this, let me tell you about something else I've got coming up in one of the videos real soon now. I bought a bunch of these Anchor. They're apparently 100 watt, 45 watt, and 22.5 watt, 167.5 watt total. As Project Farm would say, we're gonna test that. And for that, I've got a couple of dark light bulbs and some USB power delivery doohickeys. It's gonna be fun. I'm looking forward to it. I should probably have RTFM'd before I opened this, but that's not the way. All right. I am surprised, but not really surprised at how incredibly simple this is. Input, output. So the plan is I will have the one shore power connection, which I have a replacement coming. So I've got that on order, and that's going to be wired into this. And then I will use a pigtail on the shore power cable to switch to the plugs used in 230 volt countries. The frequency coming out is always going to match what's coming in. That's a concern because the frequency going into the Multiplus is what comes out of the Multiplus. So if I plug into a 50 hertz country, I'm going to get 50 hertz on the boat on the AC side whilst I'm plugged in. I'm planning to build an electric galley. I'm going to take the old Force 10 gimbaled stove that I have, get the propane stuff out, and try to put an inductive cooktop or two along the top and change the internal gibbons for an electric one. Those may not work on 50 hertz. If that's the case, and I really need to use the galley while I'm charging, what it means is I'm just gonna have to unplug the shore power connection, run off of the batteries to do the cooking, and as soon as I'm done, turn off the galley equipment and plug back into shore power and resume charging. Okay. Okay. I hope this is coming through on camera. There's a bunch of these blade style pins sticking out. I think these are basically high amperage jumpers. Where you would normally have the dip switches or jumpers to set things, I suspect the current is going through that, and so these are going to be needed to jump between whichever pins to set whatever I want. Now, with that highly technically accurate description, let's RTFM and set this up. Ooh, that is very white balanced out. I just learned what one of the buttons on my camera does. Oh, when it comes to how the isolation works, the shore power ground goes to the core of the transformer. The chassis goes to the ship side ground, and they are not connected, which is how you get your galvanic isolation. So shore cable, ship loads, that's pretty obvious. Connect the enclosure to ground, which I already knew about. Okay, so adjustment for the required input and output voltages. Okay, so this is the LED diagram. I'm reading the manual on YouTube. How exciting, but might be a reference for someone in the future. So if it's between 0 and 87 volts, so it's too low for this thing to operate, this will be on, both of the yellows will be off. Between 80 and 130, the 115 is on, the 230 is off, makes sense. 130 to 185, we're back to the on being on, but neither of these. And 185 to 250 volts, the 230 comes on, the 115 goes off. Okay, now we get to the internal jumpers. If you connect the two center pins on the output, you get 230 volt output. Okay, to get 115 volts out, I need two jumpers, and it's going first to first, second to second. So let's do that. I will cross-check myself when I get on the boat before I fire this up for the first time. Don't let me forget that. Okay. That strikes me as being kind of high, and it's going to block this sitting down properly, I think. Yes, it is. Okay, that's annoying. Okay, folding them over is probably the best thing to do. I suppose I can try maybe something like that. Okay, well, cable management will come later. Interesting. All of the jumper configurations show jumpers on both input and output side. I mean, I'm sure I just don't do anything here, but they gave me the jumpers for it. I'd just like to have the manual actually tell me you don't need to do anything for the auto. Oh, the red light doesn't mean it's overheated, it just means the fan's turned on. Okay, that's good to know. So now my earthing. If the boat is floating, connect the PE wire coming from the input PE terminal to male push-on connector J34A. Oh, lovely. They have J34A and J34A1, and it shows a link between them. Are these two connected? They are. Ah, it's a way to make it non-isolated. So what it says is if the boat is floating, connect the PE wire, which I'm assuming is one of these two. That's going to be too short, so it's going to be this one. If the boat is floating, connect the PE wire coming from the input PE terminal to male push-on connector J34A. J34 right here. Okay, so I need to connect this to here. But does that not connect the two grounds? Yeah, now the grounds are connected. I don't want that. That's the whole point of an isolation transformer. If the boat is on shore, winter period, or maintenance, the PE conductor in the boat must be connected directly to the input PE for safety reasons. So if I'm hauled out, like for the winter, like I am right now, it's saying to connect the ground, the boat ground, to the land ground. It's only when I'm in the water that I want it isolated, which makes sense. So that'll be that for now. When I'm going to go back in the water, remind me to unplug that cable, please. In fact, I'll make a label and put a label on here to say disconnect this before launching. Huh? These instructions are not clear. I think it's, I'm gonna have to look this up after this video's over, but what I think is happening is, when I'm in the water, I think I do this. This establishes a connection with the input ground, and dropping it straight over. Editing me is going to put a notice up here if I'm doing this wrong. The small cable that I labeled as being used for this jumper is not meant to be for that. This is supposed to be for linking the neutral and the earth on the output AC side. When I'm in the water, using this shorter jumper wire to link these two spades means that the ground is now tied to the core of the transformer, meaning that there is no connection between the core and the outside. Now, I'm touching this piece. I don't know if that's the shielded core or not. Point is, the earth coming in from the shore is not connected to the earth on the boat. And I should be able to test that right now, actually. There's the shipboard earth. There's the shore power earth. No connection. So now it's floating this when I'm on the shore. I'm repeating myself multiple times, but I'm just finally figuring it out in my head. I want this for the time being. I printed that label and stuck it on here, which reminds me, hopefully just visually seeing it will remind me that I need to switch the grounds between haul out and going back in the water. So that's done, that's done. Let me check to see if there's anything else I need to worry about. The fan RPM is temperature controlled, so it's a PWM fan. Inrush current limiter. So it has a soft start function, which doesn't matter to me, but if you have an air conditioner or anything with like a big capacitor, that'll help. I guess I kind of do with my Multiplus. And now I'm into other languages. That's it. That's the whole setup, apparently. I will double check this when I get it on the boat. But I think we're done. In the early days, I was really self-conscious about plugging the Patron because, you know, what did I have to offer? Now I'm not nearly as nervous or self-conscious anymore because our Discord community, it's really small. There's a dozen people there, but it's very active, very friendly, very supportive, very welcoming, and we would love to have you join if you're interested. Okay, back to this. I'm putting it back in the box because I intend to have the next time I turn everything on be in the boat. Hopefully. Looks like chipmunks got to it. I'll go through the diagram here in a minute, but I'm going to have two 12-volt batteries, each with their own separate BMS, and I have two of these. One of them now, the other one's on order already. Oh, awesome. I thought that was going to be bigger. It's not. Isolated, not that I really necessarily care that it's isolated, but that's the only flavor I could get. 30 amp, 48 volt to 12 volt buck converter. Except they called it a DC-DC converter. I think it's two ways of saying the same thing. Oh, I'm really happy. I was worried this was going to be the size of the IP43. Space and weight on the boat in the lazarette area is something I spend a lot of time thinking about these days. Screw-based output voltage adjustment. Is there any Bluetooth? There's no VE direct. I don't think this is monitored. Okay, well anyways, this takes 48 volts in, puts 12 volt out, and it puts it out up to 30 amps. So as you can see here, I'm going to have two of these coming from the 48 bus powering the 12 volt bus. I'm going to have two of the 12 volt batteries also going to the 12 volt bus. So these, I mean, they're going to act as a bench supply, so they'll provide some ability to charge the batteries, but they're not really battery chargers beyond putting voltage and current onto the bus. As I sit here and talk, I'm going to have to think about how I do this battery thing because the batteries will pull way more than 30 amps if I allow them to. Now, I could probably go into the BMSs and limit their charge current so that they can't do that, but I digress. The reason for two of them is, if I happen to need the current, if I need more than 30 amps on the bus, well, first of all, the battery's on there and it should just pull from the battery as well. But it gives me redundancy. So originally my plan was going to be I was going to have these two devices on and the two batteries on, just on all the time, good to go. But one of the things that came up with one of the folks who was helping me was, okay, but what happens if you get a dead short? As unlikely as it might be, you'll blow the fuses to both of your buck converters and both of the batteries, and then you're without 12 volt power at all. And remember, 12 volt runs my bilges and runs my navs and my lights and whatever. That's safety critical. So now the thought is, one of these adapters will be powered off all the time and one of the batteries will be disconnected all the time. So if I do have a dead short that destroys or blows the fuses of both of these, I can resolve whatever the short was and then turn the other two on and I've got 12 volt again. Now, I have decided, I'm stealing this from Steven over at Arabella. When I was down there helping him, one of the things he said to me was, I'm just going to run 10 amp throughout the entire boat and I just don't have to worry about it anymore. And I love that idea, so I'm stealing that idea. I may not rewire all of the circuits on day one, but everything I wire or rewire is going to be replaced with 10 gauge. Now, the new standard says that you should use red and yellow. And the reason for red and yellow instead of red and black is that black is the live on the AC side, it is the ground on the DC side. Don't mix these up. In my case, all of the AC is running in triplex cable. So I've got it on order, but it's not here. I've got 100 feet of 10 gauge. It's 3 wire and 1 outer jacket. So I can tell if it's one jacket, it's the AC side. If it's independent wires, it's the DC side. So that's how I'm solving that problem. Now, on to yet another topic. Okay, I'm glad I opened this on camera because this makes me very nervous. It looks like this was crushed and fixed before it was shipped to me. So let's see. I'm going to take a picture of this. Yeah, this was crushed and then taped back together, and then it's crushed again. So, this is from Vetus. I have never dealt with Vetus before, but as I understand, they're a relatively well-known name in the marine industry. Specifically, though they make a lot of products, one of them is a 10 kilowatt electric motor for boats. This is a Keel cooler. So, I talked in the past about using radiators with PWM fans, and I had all of this elaborate configuration in mind, and the more I thought about implementing it and wiring it and plumbing it, the more I got discouraged. So on a whim, I just did a search and said, Keel coolers. is there any small keel coolers out there? And I found this. I'm hoping the box is banged up because what's inside of here was bashing around. Ugh. And indeed it was. Damn. Okay. Close-ups. It's literally just an open void. There's no channels. There's some marring on the thread that makes me a little nervous. Oh, these are replaceable. Excellent. Excellent, excellent, excellent. I can swap these out to the right size if I need to. Anyways, what I noticed is this side here, you can't really see it, but it goes all the way down to its tight. Now I haven't actually tightened it down. This one didn't. There's some marring on the threads. Okay, with some force, it's going rest of the way down. It's just not machined to particularly high tolerances. Okay, well anyways, there you go. So this is probably going to get mounted. Oh, so if you remember in the engine bay, I'll overlay a picture of it here. I have 3 seacocks that are currently in the engine bay with the port side most. So looking at the engine bay, the right side most, the one I had to break the top off in order to get the rails in when I pulled the engine. There was a small one center to it. So looking back to the left of it, I'm hoping to put one of these two through that hole and then drill the other hole for the other side. Is this going to be enough? Well, I hope so. Okay, so here was the math. When you hear a 10 kilowatt motor, it generally seems to me like there's some marketing games going on. Golden Motor calls it a 10 kilowatt motor. Torqeedo, those of you who are here from the beginning or went back and watched the early videos will know, I originally planned to use a Torqeedo pod motor on the boat. Originally, when I started looking about 3 years ago, they said they had a pod 10, and then they had a pod 12. And at the time, I just thought it was a bigger motor. Now that I understand how this stuff works, I think what they did is they started looking at the input power instead of the output power. Hard drive people know the difference between gigabytes and gigabytes and all of the mess that has. So I hate marketers sometimes. Anyways, point is, the 10 kilowatt output motor takes 13 kilowatt at full thrust, meaning I'm losing 3 kilowatt to waste heat. Now, it doesn't all go straight from the motor, it's venting into the air, the metal itself, blah, blah, blah. Point is, I need to be able to remove, if I remember my math right, I'll put it up here. 3 kilowatts is about 9,000 BTU, I think. I expect to almost never run anywhere close to that. But if I am running at that speed, I need it. So I need to know that I can run at full power as long as I can possibly think I would do that, which like an hour. Say I have to be able, I want to be able to do it for at least an hour without overheating anything. This is rated for 12 kilowatt. In the same way the Torqeedo called their 10 kilowatt motor now a 12 kilowatt motor, I'm kind of thinking that Vetus might be doing the same thing. In their 10 kilowatt motor, they're calling a 12 kilowatt motor because they're looking at the input power. Mine goes to 13, there you go. If, for some reason, one of these isn't enough, the nice thing is I can put a second one on the other side of the center line and just series connect them. I don't think I'm going to need that. We'll find out this summer when I'm in the water and do load testing and sea trials. Wait a second, there should have been a pump with this. I need to talk to Defender where I ordered this. Anyways, I'll get back to that in a minute because telling you this just made me realize when I was reading the specs on this, it said that it only uses 8 watt while cooling. I thought that meant that this was going to come with a pump. I don't see a pump in here. So I don't know where that 8 watt number came from. I am really annoyed that there's no pump here. I'm going to have to go back and look at that. It didn't even give me a tube of seal. I mean, there might have been, and it fell out of the box. Anyways, that's another part of the thing. Now, on the topic of metal, heavy metal. Sorry, I'll never do that again. I found a shop that will make me a new prop shaft. So I don't know if I showed it on video. After 43 years, even though the boat wasn't used very much, you could see divots where the stuffing box bit down, it was worn. Where it went into the cutlass bearing was worn. It was straight, it wasn't bent, but there was enough divots in it that it probably would never make a good seal. I don't know if I'm going to need to make it longer. That's something else I've been doing a lot of research into, but one thing at a time. The prop shaft I had was 55 inches long, whatever this is in metric. I've asked for the new one to be 60 inches long. I know I don't need it to be that long, but that gives me the length so that when I test fit it on the boat and I'm figuring out where I'm going to put the thrust bearings, I can line it up, put a mark on it, take it back to him, and he'll weld a ring in. Now, how we're going to do the thrust bearings. This was something that I spent a lot of time trying to figure out as well, and this gent helped me with it. Basically, we're going to have a big washer that is going to sit over the outer dimension of the stock of the prop shaft, and it'll get welded on once I've got that alignment properly, and then the thrust bearings will clamp on to either side, and they'll interface to the prop shaft. The part that spins will connect to that washer that's going to be welded onto the prop shaft. That means that I can take the thrust bearings off and pull the prop shaft out. If you remember, I have to sort of pull it out and kink it to the side to get past the bulkhead that separates the main saloon from the aft quarter area. This design will let me do that. And the outer parts of that will clamp onto whatever the face is that the motors mount to. Okay, so that is all of the parts right now. So let's talk about the wiring diagram. So as I mentioned, one of the things that I have been really struggling with, and I'm still not sure I've got it right, is grounding and bonding. Because I'm going to have a radio bond, a lightning ground. I don't have to, I want it. I'm going to have a lightning ground. I have an AC ground and I have a DC ground. So let's start with the isolation transformer. I mentioned when I was configuring the isolation transformer that the ground has to go to the transformer shield. I was calling it a core earlier. And the chassis becomes the connection point for the ship side ground. The neutral and the ground on the AC side is bonded at the isolation transformer and nowhere else. One of the things that I'm currently trying to figure out, and I've got a couple people who said they're helping me look in, talking to experts to see whether this is needed or not, is so long as I understand it right now, so long as the line from the shore power plug to the isolation transformer is less than 10 feet, 3 meters, I don't need anything. I don't need an ELCI for sure, but I don't believe I need a breaker at all. There's debate around that, but nobody that I've talked to so far is clear on what the right answer is. So the same gent who sponsored me to be a member of ABYC is asking around to see whether do I still need to have a regular 2-pole breaker between the shore power connection and the isolation transformer. As of right now, I've got it marked as if the regular 30 amp breaker is between the isolation transformer and the inverter. While I was doing this, I really wish I had taken a better inventory of the breakers that I have on the boat already. What can you do? However, I still wanted to replace the breaker because the main circuit breaker on my boat is probably original to the boat. On the output side of the inverter charger, it goes to the AC distribution bus. And here's where a few things are a little bit up in the air still. I have the gimbaled Force 10 stove that was propane powered. I want to find at least one, if not two, 120 volt induction hobs that I can mount into the top. And then the second one is, about 15 years ago or so, my ex and I were living with his grandparents, and we were in the basement and there was only a 120 volt outlet, and we wanted a better oven than the toaster oven we were using at the time, and we found this. It's a Vollrath 120 volt 15 amp caterer's oven. So it's a commercial oven designed for caterers, so that's why it's only 120 volt 15 amp. They wanted to make sure that it could be plugged in to any standard wall outlet. I have been using this as my only oven ever since. I love it. It is super efficient. Yes, it's disgusting in there, like I said, 15 years old, but it's just standard electric elements. Obviously, when I either rent or sell the house, whoever comes into my house next is not going to be okay with this. So this ends with me. Because of that, I don't feel bad gutting this. So my current plan is to take those elements out, and the fan or whatever, and this bitty here, the control stuff, and try to physically fit it into the Force 10 chassis that I've got. For this reason, I am planning to run just to save on breakers, a single 30 amp circuit to where the oven is going to be, and I'll put two 15 amp outlets on there one for the hob and one for the actual oven itself. The reason for the 30 amp is I can just run both at the same time, which I don't plan to do very often, but if I did, it would be able to do it without popping a breaker. I plan to run a second 20 amp. That'll be for the kettle, for the rice maker, and for whatever might get plugged in around the galley. I'm going to have the Phoenix 15 amp charger. This little hero, which is going to be the primary way of charging the 12 volt batteries on the boat. Currently on the boat, the head, the starboard settee, and the V-berth are on one circuit. I want to put the head on its own circuit. And just in case anybody, I want to have crew on the boat, and I want to make sure any crew that's on the boat is comfortable. So if I have crew that wants to use a hairdryer or curling iron or something like that, they have a dedicated outlet that won't be tripped if somebody's in the V-berth or using the outlet on the settee. The V-berth and the starboard settee, so the ones that are already there, I'll probably keep that same wire, just bypass the head and leave that, because as far as I can tell, everything on that is just fine. I'll change the outlets just to update them, but I think the wire is fine. I haven't decided yet whether I'm going to keep that outlet at the nav station. I suspect I'm probably going to get rid of it. I'm going to completely rebuild where all the breakers are. One of the problems I had, if you remember when I was mounting the compact, the 12 volt charger for the trip home, the outlet, the 110 volt outlet in the nav station actually sticks into the lazarette and made it so that I couldn't really use that space to mount something. I need that space back. Under the companionway, I'm going to put a drip tray, so if any water comes in, it won't run back and down into the breaker panel area. It's never been a problem on my boat, I don't think, but it would make me feel better. So if I do that, if you recall, I put the 20 amp outlet for the quarter berth. I'm going to take that out and move that over, and that'll become the outlet for the nav station, for the companionway if I want to run an electricity out into the cockpit, or for whoever is sleeping in the quarter berth if they want to use that. And the last AC circuit is going to be for the hot water heater. Nothing terribly fancy here. All of the AC grounds are going to tie back to a common grounding bus. Now, before I go into the DC side, because that's a little bit complicated, let's talk about lightning protection. So as I understand, TE04 is the AVOIC standard on electrical grounding. I need to measure my mast, but if my mast's cross-sectional area is greater than 100 square millimeters, I can use the mast as the primary conductor. If that's the case, then I need to put a aluminum metal conductor that sticks up, so it's the highest part sticking out of the mast, and I should be able to just bolt it onto the mast, and the mast becomes the conductor. Operating under the assumption that the mast is big enough to be considered the lightning ground, what I'm going to do is drill a hole, maybe two, at the base of the mast on the starboard side, because that's the side whenever I'm walking into the boat, when I walk into the saloon, I can see that side of the mast all the time. So if I drill and tap that and I put the grounding wire onto that, if it ever starts to corrode, I'll see it right away. If it's on the port side where my feet are, I won't see it. That's going to go down to a grounding plate, which I have not purchased yet because I have to figure out the right size. But I'm going to have to drill a hole through the hull near the base of the mast, because if you get struck by lightning, you want the shortest possible connection to ground with the fewest and mildest bends that you can possibly get. So I'll have a long wire that goes up the mast a little bit so that I can run it as relatively straight as I can. It won't be that pretty, but safe is more important than pretty. That'll go to the grounding plate, and that'll become what used to be the engine ground. So I will run a grounding wire back to the engine bay, motor bay now, and that'll become the ground. I'll put a ground bus there, and everything else electrically could tie into that. I don't know where I'm going to tie the radio ground in. I haven't got that far in the design, but the grounding coming off the mast will go straight to that grounding plate. Like there's a bolt that's going to come through. It's going to get directly connected to there. And then another bolt goes off to a grounding bus for everything else. All of the AC grounds will connect back to that. The ground from the output side of the Multiplus will tie into that. The ground from the isolation transformer will tie into that. All of these will tie into the bus that goes back to this isolation plate. To the immersed ground plate. Let's now come down and look at the 48 volt side, which we've already seen a lot, but I've had to put some more thinking into it. Doing this drawing, for anybody else who's doing a conversion or any kind of a major refit, I thought I had a lot of it figured out in my head. The last 3 days, literally my entire weekend and much of today before I pulled out the camera, has been spent trying to draw this out, and I have caught myself with so many design mistakes. I would have been very upset if I had found these mistakes after I built the system. One of them was, Originally, I had planned to run all of the batteries, the inverter and everything to those 2,000 amp bus bars that I had bought. And that worked here because I only had one charger. As soon as I introduced two different charging sources, and I'm going to have solar, two of them, two MPPTs and two solar arrays, I'm going to have regen from the two controllers, so there's two more charge sources, and then the shore power connection. I had to make sure that all of the current coming in and out of the batteries went through the smart shunt. Otherwise, I wouldn't see it and my state of charge would fall out of sync relatively quickly. So one of the things I've done now is all of the batteries go to their own dedicated bus, and there's a single connection out through the smart shunt that goes to everything else that uses the 48-volt system. So I can track all power coming in and out. I've done a similar thing on the 12-volt side right here. So you can see the same thing. I've got the, it's only two, so it's only a two connection ground bus, but regardless, the two of them go to the smart shunt, and then all other 12-volt charge sources and loads go through the smart shunt. Now I make sure that I've got accurate tracking of them. Back to the 48 side. So I've got my two solar panels, which are fused. The panels are fused going into the MPPTs, and then the MPPTs are fused going out to the bus. I'm marking these here as having the fuses close to the bus bars, but in reality, they're going to be as close to the source of power as possible. Next, I've got the two motors on the 48-volt bus. So I've got the contactor and I've got the maxi fuse. This is the fuse that's built into the controller going to the motors. And obviously, I know the arrows here are only one direction. I chose the direction where power is going to be flowing most aggressively or most often, but obviously it can go both ways. Now, coming off the 48-volt bus are the DC-DC adapters that power the 12-volt rail. So originally I had this idea, and I probably mentioned in previous videos, where one of my two bilge pumps would be run off the 12-volt and the other one would be run off of a buck converter. That didn't make a whole lot of sense to me when I sat down and actually tried to wire this up. Both of them are off of the 12-volt bus as a power source, and it doesn't matter which one. It doesn't matter how I'm providing power to that 12-volt bus. If there's power on the 12-volt bus, both bilge pumps will become available. And last, I've got a single 12-volt MPPT. The primary reason for that, it's going to be a small little panel I mount somewhere, maybe two of them. So on the bimini, if I look up, the space between the two 12-volt becomes the window to see the masthead. I haven't decided exactly that. Point is, it'll be a small 12-volt panel whose job it is just to keep the 12-volt batteries charged up if I've got the inverter off, because with the inverter off, the IP43 charger's off. And I don't want to leave the inverter on when I'm away from the boat. The bilge pumps, they don't go through breakers. There is a fuse on them, obviously, but they don't go through the breakers. So if I have the main DC bus off, the bilge pumps have to still be powered. It's how it is now. It's how it will be when I actually rewire the boat. Also, you'll notice that there's a float switch and there's a manual switch. So I've got that lever where I can either turn the bilge pump off entirely, run it manually, or put it in auto mode where the float switch turns it on and off. Same thing, just double now. So going through the main DC breaker, which is that little one that you saw on the right, picture here, it feeds the three DC panels. So currently there's the two off to the side and the third one is set back. I have added a lot of devices to this. Some of the devices I won't have when I go in the water, but at least now they're planned for. So I have two lighting arrays. I'm going to talk about this more in a second, but I want to make sure that I can turn on all of the nav lights from the helm position. And on the interior lights, I'd like to be able to turn the lights all on and off from inside the saloon. Currently, I have to go to the main breaker panel, which if I'm navigating and I can't really leave the helm for whatever reason, it makes it hard to turn my lights on if it's at dusk, for example. So to do that, I want to have them all relay switched, but I'll talk about that in a second. Point is, I have two lighting circuits now, exterior lights and interior lights. I have marked this for Starlink. Whether it's Starlink or some other option, that'll be powering whatever I use for the internet. Water maker, I've got this on the 12-volt bus. I don't know if it's going to be a 12-volt device. It might end up being an AC device. I'll decide, but at least now I've got it here. Radio AIS, so whatever circuit turns on the radio will also turn on the AIS, because I believe they're actually tied together. Radar, computer networking. So obviously I'm going to have computers on board, and that's a whole other topic I'll talk about later, but I have a dedicated circuit for powering that side of things. One of the reasons why the computer stuff is on the DC side, and one of the reasons I wanted to buy these little doohickeys, is these give me up to 20 volts, which is what most modern computers use, including the Raspberry Pi, the MacBook Pros, and more computers are using USB-C charging. So I'm updating the sockets to 20 amp capable. In theory, I should be able to power almost everything off the DC bus thanks to these power delivery USB-C doohickeys. The AC side, I'm hoping to actually just turn off the inverter most of the time. And then there's going to be the diesel heater. Like I mentioned, I've bought that. I'm setting that up. That's going to be its own video, hopefully soon. I've got 2 that are open for future use. And now my pumps. I've got the freshwater pump, which I already have, the shower sump. Those 2 I already had. What used to be the macerator is gone now because I don't have a macerator anymore. But what I have added but haven't purchased yet are, I want a cockpit pump. So if I can basically take a shower in the cockpit. The anchor wash pump, again, this doesn't exist, but I'm going to wire for it. I want to have a pump at the front because this is one of the things I especially noticed when I was sailing with Reese, is how much mud came up on the chain and the anchor. Obviously, if you're in a muddy area like you are in the Maritimes. You'll notice that I do not have a windlass circuit. The reason is, I don't know what windlass I'm going to get. So for the foreseeable future, I'm sticking with the manual windlass. Keel cooler pump, that is for the Keel cooler, which I apparently still need to buy the pump for. Frustratingly. And then the fridge compressor. And then I've got 5 dedicated breakers, 1 for each one of these, because again, this can deliver, apparently, we're going to test, 167.5 amps over a 12-volt source is like 13 amps. So I put each one of these on their own breaker. I'm going to have one of these at the helm, one in the companionway, so that'll be useful for either the nav station or the quarter berth person. There's going to be one at the port settee, the starboard settee, and one in the V-berth, hence 5. Possibly 6 if that's how I end up powering the computer stuff. Helm auxiliary, and then helm the logic board, all of the this stuff, which we're going to be returning to before much longer. Battery monitor. So recall that I used a buck converter to power the screens, and then I had that little incident. Whoa! Sparky fire. Now the idea is if I end up sticking with the JKBMSs, or if I launch with the JKBMSs and then replace them later, I still want to use those screens, I'll just power them off of a dedicated 12-volt circuit. So if I want to see all of the screens to see the status of the batteries, I can at least flip the breaker on. That'll power up those LCDs. I can see what I want to see, and then I can shut them down again when I'm not using them. And the last one is the motor bay blower. Now, the last thing I want to talk about is the lighting array. So I am looking at a couple of the STM32's smaller, much smaller, L series, low power, basically the smallest, lightest weight little STM controller I can get. And its job will be to power a bank of 8 relays. Each relay, in turn, powers one of the lights. So for the external one, I've got the nav lights, steaming lights, deck lights, tricolor, anchor light, running lights, and search light. Not all of those exist right now, but they will. And then I think that's 7, so I'd have an 8th one unused. In order to meet ABYC standards, it's basically digital switching, except I'm just rolling my own because I want to be able to have the helm controller STM32 talk to the STM32. If you remember when I was unstepping the mast, there's that little locker underneath the port settee where all the wires coming out of the mast came in. That's where this will be and the relay array will be. These are going to be latching relays. I'll talk more about this when I actually get into it, but it's partly for not needing to energize the coil all the time, but also if a relay fails, I want the light to stay in whatever state it was in at the time the relay failed. They'll be socketed so I can pull and replace the relays really quickly if necessary. There has to be a bypass fuse. So if the relay fails, I can take a fuse and plug it in, and it'll basically bypass the relay and energize the light. So if I really need to, if the thing completely screws up, I turn my nav lights on by inserting and pulling fuses. And how will the two talk to each other? I haven't decided yet. And the second is for the interior lights, of which currently there's only 3 circuits. I will probably add more, but as the boat is wired right now, I have cabin lights 1 and 2, and I have courtesy lights, which are these little cute little foot lights that I've never used, but exist, and they do work. I tested them once. Okay. When I sat down to record this, I thought, this is going to be a nice short little video. I don't think it's going to be actually short. Well, you'll know because by the time you hear me saying this, you're towards the end of the video. Regardless, here's an update of everything that's been happening. So, one of the realities of a project like this is massive respect to the people who are building boats or refitting boats who put out a video every week. God, that's hard. I don't know how they do it. Reality is, especially when it's not your full-time job, you work on the project when you can, and even when you are actively working on the project, sometimes there's just not a lot to show. That's where I've been in since Christmas. So, there's going to be a flurry of videos once I start hitting these breakpoints. I mean, first I have to buy a truck so I can get back to the boat. But anyways, I digress. There's going to be a bunch of videos coming. I just have to get through the homework side. I haven't talked about the pulleys yet, the synchronous slash timing belt type pulleys, and sizing the pulleys and sizing the belts and learning how all of that works. Because everywhere I've called to ask, hey, I want to run these type of loads, they're like, we don't do engineering work. Or we'll do engineering work, but you know, money. So I have to figure all that out for myself. But that's my last big unknown for going in the water is what size pulleys am I going to use? How am I going to build that plate that mounts the motors? How am I going to set it so that I can quickly tension and release tension on the belt so that I can move the belt between the two motors? That's the last major thing to figure out. As I sit here right now, it's January 20th, so I've got about 3 or 4 months to figure that out. I'm trying to get all the electrics sorted out so that every time I go to the boat, I've got wiring I can do, even if I get stuck on something else. I am doing everything in my power, including selling my car, to make sure I go in the water this spring. So, more videos coming. I just, as always, don't have a release schedule. Hopefully they'll be as soon as possible, but please don't doubt I am working hard behind the scenes. Thank you very much. I'm the Digital Mermaid, and talk to you soon. Do you want a treat? Do you want a treat? Come here. Poor oscillator.